Hi, this is Chong Kim. Welcome to Ruby Chess version 4, part 3. So let's take a look at to see where we are. Okay, we have a failing test, but that's only because we set our expected to some dummy value. So let's just, for now, just copy and paste this in there. Okay, and see if it passes. Okay, it passes. Um, I noticed that my Vim is acting very slow, so if I go to the right like this, it takes a while, and that's because of I suppose it's trying to match the braces because of these brackets that are across multiple lines. But if I close them up like this, and if I go back here and I try to go to the right again, now I'm at normal speed. I think there's a problem with Vim, so that's something to look out for. Okay, so now that we have this passing, we can do some refactoring. One of the refactoring I want to do is change all um, these pieces from a string to a symbol. The reason why is because if I go to prime and take a look at this as the ID, we see that this is an object with this ID value. If I do it again, it's a different ID value, which means that this string A is different from this string A. But if I have a symbol and I do it again, it's the same symbol. So um, So I want to change it into symbols. So let's do that. So I'll look for anything that is a one character string, and I'll create a macro so that uh, it it changes into a symbol. Okay, so let's look and change these things. Okay, that one we leave alone. This one we change. Okay, save. We'll get some errors, and we'll go into our code and look for them over here. So we leave that alone. Actually, for this, we want to convert this to a symbol. Okay, and take a look at other spots. Okay, this one we also want to change. We're looking for the symbol K now. Okay, leave that alone. Okay, change all of these. Okay, change that. For this, uh, we need to change this so that um, it's a list. Okay, and we don't need to say characters anymore. Okay, let's look for some more. Here's another one. This one we're going to leave alone, but then at the end over here we're gonna convert this to a symbol. And for the promote, we're going to do the same thing if it exists. Okay, let's take a look. Oh, for this, let's just say that we'll create a method called pawn to test if it's a pawn. And okay, we're going to leave that alone. The piece we do want to change. Okay, we want to change over here. Okay, we want to change all of these. so we're back. Okay, so we need to actually for those. Let's take a look at all the pawns. Okay, so this one also needs to be changed. And the king also needs to be changed because we're going to change this to king. Okay, so let's look for, and for possible moves, here's a list of strings here. Okay, because they're not characters anymore, we don't need to say cars. Okay, all right, so let's take a look. Okay, so let's create a pawn method for symbols. Symbol and the pawn, and this will be testing against capital P or lowercase p, and for the king we're going to test against capital K or lowercase k. Okay, so we have another one, 191. Okay, so this is going to be a test for king. I actually forgot the question mark. Okay. All right, 209. Okay, so this is going to be a test for a pawn. Okay, so everything passes. So we managed to refactor everything, and it still runs in a pretty good amount of time. Okay, so let's take a look at some other things that we want to change. Okay, so it would be nice if we can just have this as see, as brackets, and instead of this notation, we'll have this notation, just to make things a little bit shorter, so we are a little bit easier to read. And change this, and the rest will leave the same. So we'll need to do the same thing for this. Changes to brackets. Move this. Oops. Move this over. Get rid of that, and do the same thing for here. So get rid of the new. Change this and change it to the new format. Okay. All right. So this makes it a little bit easier to read. Let's see if there's any others. Okay. All right. Okay, so we're missing the bracket. So let's write a test for it. So it expects the position with a rook at e4 to be the same as a rook at e4. Okay. Okay. And let's also have a test. So rook at e4, and I take a look at the board on e4, and that should be a rook. All right. So it's really a convenience method. Let me see if a good place to put it. Let's put it right, actually not over here, but over here. And let's put a little spacing in between these methods. Okay, so it's a self, so it's a class method, so we put self, and it takes options. And all it is just calling position new with those options. Okay, so everything passes, so far so good. The other thing that we kind of missed out was, let's see, two args, that this only allows you to put one rook in here. So if I go back to the other position, okay, so if I go to the position over here, I should expect that the position with a rook on e2 and e4, let's say, then I should be able to say board on e2 should be a rook. And also that the one on e4 is also a rook. Okay, am I missing something? Yes, I'm missing brackets over here. Okay, so we need to handle the situation where you give it an array. So let's do that in the initializer. So this is where it's being handled. And so what we need to do is, okay, so it's going to be coming in as indexes with an S. And we're going to set this, we're going to make this into an array unless it's already an array. Okay, so this way, now that we know it's an array, we can just go through each one of them. Okay, so this passes. Okay, so now we can have multiple rooks. So we're able to set up the board. All right. So what I wanted to do is, when we take a look at these possible moves, these are really hard to read. So what I want is to print it out in algebraic notation. So let's start the testing right here. So if I have something like, well, this will be, we'll call it move stir. So we'll start off with something like, actually, we can just start off with position. So we have a rook on e4, and we say move stir from e4 to e2, and that should give us a string that's rook e2. Fairly straightforward. And if there's any ambiguity, so if I have a rook on e4 and e2, and I say move stir e4 to e3, then saying rook e3 is too ambiguous because the rook on e2 can also go there. So I should say rook 4, the fourth rook, to go there. Another situation is if I have another rook at the same row. So if this was on a4, and I say rook e4, e4 goes to b4. Then I can't say rook b4 because there are two rooks. So it should be b4. Okay, so let's save this and see what happens. So we go here to, okay, let's find a place. I'm going to put some spacing in between these methods so that it's easier to maneuver, because then I can go paragraphs at a time like this. Okay, so Okay, so let's start with, let's create the function from to, and just run it so we can get the error. So we're expecting rookie 2, so let's get the piece, which is from the board, from, and the string is going to be um, the piece and 2, and we convert it to the square notation. So we've passed the first test. Now we have to make this happen. Distinguish it by the column. So we'll use a find to help us. So find is going to return us a list. So find the piece that can go to this location. And if there's only one, so if list size is 1, then we can just do this. Otherwise, we'll take the list and we select it based on the index if there's only if you do it by the column, see how many are in the same column. Dot size. If there's only one, then we know that we can just do um, designated by. Now we have to convert this into a column. So you have the from, and we'll just add it to. Remember that the 0th item is a border, so it starts from 1 and a, but then we have to subtract 1 from it uh, because of the border. And in order to print it out, we need to say car. Okay, so this turns into a letter. And then we can specify the 2. Okay, let's see. Okay, so that passed, and now we're up to the next part. Okay, for the next part, it's based on the row. So we're looking at the row now, and we need to subtract it from 8. Actually, we can just use a number here because yeah, we don't need to turn it into characters. Okay, so we basically this starts from 2, so we have to add 2 to this. So if this was on row 8, which is on the first row, which is the 0th row, the index position would be 20, and so divided by 10, that's a 2. So we want this to actually become an 8. So we have to add 2 from this to offset. Okay, so let's see. We're missing something here, so parentheses. Actually, we don't need parentheses for this one. Okay, so let's see. So everything passed, which is really good. Let's do bishop. Because there's a situation with a bishop where if you have a bishop on, let's say that whatever bishops you have, you want to move from, you want to move to the e4 square. So let's say d3. So let's put a bishop on d3, d5, and then on the other side f3 and f5. This is a very highly unlikely case, but it can happen, so we should handle it. It can happen because of pawn promotion to a bishop. Okay, so if in this case is ambiguous in terms of both row and column, then this should be very explicit to say the d3 rook to d4. Okay, so it just spells it out. All right, so let's see what happens here. and undefined method board for string 85. Oh, I said move. It's supposed to be move stir. Okay. Expected but got nil because belongs in this other case now. So in this case, this is a very interesting case because then it is just using from to square to square. Okay. All right. Oh, that's correct. This should not say rook. It should say bishop. Okay. E said. Okay, so yes, right. It is E4. All right. Some other things that it should handle is if you have a pawn. A pawn move should not display the piece. So if I have a position with white pawn on E2, and I happen to say move stir E2 to E4, then that should give me E4. Okay, so instead it says pawn E4, and we can just say if the piece is, well, let's just do it here. Piece is equal to blank if piece is a pawn. Oh, actually, we need to do that after. Here, like this, because we want to find the piece first. Okay, so this passes. Okay. And if there's a pawn capture, pawn on E2, and let's say there's another black pawn on D3. And if I say move stir from E2 to D3, which is a capture, then it should say ED. Move stir. Okay, so instead it got D3. So we have to have special conditions for a pawn. So let's see. For forward motion, this should suffice. This logic should suffice. But if it's a capture, if let's do a case piece, and as for this, let's instead of I'll call it piece stir, and okay, so let's just take this out. If it's a pawn, then it's just going to be an empty string. Otherwise, it's the piece itself. And we'll just change all these pieces here to piece stir. There's one more over here. Okay, so if the piece happens to be, when it's a pawn, we'll handle it as a special case. Actually, no, this should be an if, because the logic is a little bit more complicated. So if the piece is a pawn, and it's a capture, so that means board 2 exists. And or it could be an en passant capture. So we'll just say capture. And is capture. So this capture happens if, okay, So it happens if the board 2 exists or it's an en passant. And it's en passant if piece is a pawn and two is equal to the en passant square. Okay, so we have, okay, so now we have the is capture here, then, and we have the else case, and this whole thing falls into the else case. All right, so if it happens to be a capture, for now I'll just put an X here. It'll fail, but okay. All right, so we know we're in the right spot. So I realized that for this logic, instead of using this logic, this is kind of long. I could actually do it in a different way, which is a lot simpler. I could say from to square and give me the, and if this is the column, so it's the 0th item. And I could do the same thing here, the from, convert it to a square and get the 2nd item. Okay, so this should simplify things a little bit. Okay, so same error. All right. So if it's a capture, then I wanted to say from square, just a column, and the to square, the column. Okay, it passes. All right, so but there may be some ambiguity, so let's take a look at some of the cases for ambiguities. So if I happen to have a pawn on e2 and e3, and a pawn on, okay, a pawn on d3 and d4, so now we have the ed, so it could be either this pawn or this pawn. So this would be more explicit and say ed4, actually d3. Okay, so let's figure out what we need to say in order for this to work. So we have the columns set up, so we want to see how many pawns that, okay, so if there are 2 pawns, okay, we need to find all the pawns. Actually, let's see. We could say find the pawn that can go to 2 square, but this is not going to help us. Because what we want to do is we want to go through all of the column. So we know the column, the 2. So we can actually go through it all. So let's think about this. So in order to print this out correctly, we would have to start from, oh, we can just do it 8 times. Okay, so 0 through 7. And so this would be the row. And we have the column, and the column is actually from okay, so that this would give us the column. plus row times 10. All right. So if we want to, actually we can probably do a select here. Select all the rows where this location, so we're looking throughout the whole row for this column, and we're looking for pawns. Well, the piece. All right, and so this will give us a list of possible pawn positions. And we have to see how many of these can actually take. Okay, so we're gonna need to filter this again. So okay, so we have the row, which is a smaller set now. And we're going to see how many of them are able to take. So that means that it is from it's going to be +1 and minus, actually the 2 column actually. Okay, so we're looking at the 2 column now, and we're going to go through the row times 10, and we're going to see if that's okay, board, the piece that's located on the two column, see how many of those exist, is equal to, actually we say the color. Let's say target, and then we just say target, and target color is equal to does not equal to the piece color. So it's the opponent's piece. So how many pieces am I, how many pawns of these list am I able to take? Okay, so this should be, okay, I'm just going to assign this. Actually, I could just say select bang. Okay, so now it's modified. Now I can just test it and see if this, the size of this is equal to 1, then we just do the normal. Otherwise, we're going to do it the more elaborate way. So we say from to square 0 and to square. Okay, so let's see. All right. Okay, so let's see. We only have one pawn here. So to get d3, that's very interesting. So let's put a debugger here and see what's going on. Okay, so let's take a look at possible pawn position. It's empty. Interesting. It should have found at least one. So let's see where it went wrong. So I'm going to quit out of this and move the debugger up to the beginning here. All right, so let's see the first one. It's empty. That's interesting. The piece is a pawn, and the board oh, Oh, I forgot about the border. Okay, so that's okay. The border, because of the border, we have to add 2 to this. Okay, so let's see. Okay, we still got the wrong answer. So let's do the debugger again. So we have something for the first one, which is good. For the second one, let's see. Oh, the second one. Hmm. Yes, the second one. Yes, the formula is wrong. The formula is wrong because uh, the row, depending if you're white or black, uh, it will. Okay, so let me just say, if you're white, then you don't want it to be 2, you want it to be plus 1. And if you're, um, otherwise it's 3. Okay. Because of the direction, it's offset by 1 uh, in one direction or the other direction. So it was supposed to be 2. So actually, I could have said 2 over here. This is probably a little bit more readable. Um, okay. This would make more sense. So we have the offset for the 2, and depending if you're white or black. If you're white, then you want to subtract 1 because the attack square is going to be above you, and plus 1 because it'll be below you if you're black. Okay, so this should be more correct. Okay, color for symbol. Undefined method color for symbol. So we'll create one. So for a symbol, um, return color unless color is nil. It'll be a nil initially, so we'll set the color to be we'll do it based on A. So if it's greater than A, then we know it's a black piece. Otherwise, it's a white piece. Okay. Okay, so everything passes. So we have a piece movement, rook, bishop. Queen, king is not going to be that much different. But um, actually, we're done with the pawn. Now for the king is interesting because of the castling. So if I have a king that is on e1, let's just say e1 and just say move stir from e1 to e2, then it'll just be what we expect, is king e2, and this should pass. But if it's trying to do something special like castling, so we have a king on e1 and a rook on h1, and we try to move the king from e1 to g1, it knows it's trying to castle, and so it should return us a castling move. And same thing if it's on the other side and we're trying to castle long. Okay. All right, so let's get cracking on that one. So, okay, we're not in the right place. Let's go to move start. Here we go. All right. So in this case, it's a king. So and it's trying to move. It's trying to move 2 squares, and let's say uh, and from minus 2, let's say absolute, is equal to 2. So it's trying to cancel, basically. Um, so in this case, we're going to print it out as, I'm assuming that all of these are legal moves because the legality of the move is going to be checked somewhere. Okay, so in this case, the let's see, I'll just say, actually, there are two cases here. So if this is equal to 2, let's say 2 minus from. In this case, okay, if it's a 2, then actually, yeah, then it's a regular castle. But if it's a negative 2, then it's a long castle. Okay, so everything passes. So now we have almost everything that we need. I think we probably have everything that we need in order to change these tests. So the possible moves, we're going to, we have a from and to, so we're going to map this. We have a from and a to, and we're going to say, um, we need a position here. So um, so okay, we need to store this as a variable. So position is equal to this. Actually, possible move. I'm going to turn this into, okay, let's change this to a do, and we'll set this up. So position is position with rook on e4. Okay, and then we can get rid of this, and see position and map position move stir from 2. Okay, and I'm just going to start a new, actually I'm just going to, let's delete this whole thing and say it's equal to empty and see what it comes with. This one would, see, oh, see where this ends. This matches with that, equal to this, and all right, let's see if everything matches up, because like kind of, okay, so let's see what happens. All right, now this is a lot more readable. So I'm going to take this, I'm going to copy it in here, and I can actually verify if it looks right. Okay, and since since it starts over here, I'm going to just put a backslash, and so this way it just continues here. Should work the same way now. Okay, all right, so everything's the same. Okay, so let's take a look at this. So we got rook a4. Okay, so the rook that's on a4 can go to e4, can go to a4, b4, c4, d4, and it can go up to e8, e7, e6, 5, 3, 2, 1, and you can also go to the right. So rook f4. So all these look right. Okay, so this is perfect. So let's see how this would affect this position. Actually, you know, this I think it's probably better if I wrote it as as this. So the subject is this, and change this to it, and instead of position, it would be subject, possible moves, map is equal to, and just take this out and put it up there. Okay, so this is a little bit more compact. See, context is rook move. Okay, the context for this is bishop moves. Okay, so the subject is position with a rook on, not a rook, a bishop on e4. And let's see what this looks like. So I'm going to change this position to subject, and we're going to map this from to from to. Okay, and backslash. All right, and for now we'll just say it's empty and see what it comes up with. All right. Oh, undefined position. It's not position anymore. Subject. Okay, so I'm going to copy this. And place it right over here. Okay, so everything passes. So now I can eyeball this. So E4, A8, B7, I can see that it's going diagonally. Um, uh, so this looks like it's actually sorted in this way. Okay, so A8, B7, B1, C6, B2, C2. So from here to here, that's a diagonal move. That's a diagonal move. Okay, so this looks right. G2 to E4, yes. Okay, so all of this looks right. And let's take a look at this. And seems like we're reproducing this a lot. And possible moves. I'm thinking that possible moves, okay. I should create another function so that it would be possible move stir. Okay, I think that would work. And still testing possible moves. So let me just do it this way. So if I'm doing this way, actually, okay, so let's just simplify this. I'm trying to reduce the amount of code. Okay, and right. So this will, oh, okay, so we have to make this parse. Get rid of all of this. Just simplify. No method possible move stirs. Okay, so let's write move stirs. So let's go to possible moves here, and Okay, so that takes a list of possible moves and maps the from and to uh, move stir from to. Okay, everything passes, so this is good. Because we have that convenience now, we can probably put this back in here. And yeah, we probably don't even need this anymore now. We still need to break this up. And okay, and take this out. All right. Um, okay. So, and get rid of this. See how this works. Okay, so far so good. And now for this one, possible move stir. This makes it a little bit easier now. And to equal something. We don't know what that is. Let's take a look at the results and see if this makes sense. Oh, there's a character turned there. Okay, so this passed, but we see that there's a castle here. And let's see, does this look right? Okay, so here are all the king moves. So the king is on e1, so d2, d1, e2. Actually, let's just sort this. All right. Okay. Okay, so it passes. So let's take a look at all the king moves. The king, d1, d2, e2, f1, f2. So far, so good. And uh, castle, that's also an option. Rookie, and here are all the rook moves. So rook e1, f1, g1. Okay, and then it can go vertically. So h2, 3, 4, 5, 6, 7, 8. Okay, so this is really good. So I think, okay, so I think this is, let's add one more. Um, okay, so let's see what happens if there's a rook on a1 instead. So I expect that, uh, well, let's see what happens. Okay, expected but got this. Um, okay, it's on a1. Okay, so there is actually a little bit of a problem here. Okay, so let's take a look. Got this. Okay, so let's see. This one matches with this. Okay. So king d1, d2, king, and this says castle, but this is not true. It should really be long castle. like this. And the rook can move here along the A file, and then it can move across, so B1, C1, D1. And it says rook E1, but that cannot be. You can't move to E1. So that's out. Okay, so and here this one also says rook E1, so that cannot be exist either. All right, so we're just fixing a few things here. So the king can go to D1, D2, E2, F1. Okay, it's much easier looking at it like this than it was before. So we can see some obvious problems with the way possible moves work. I think this is a good stopping point because we made enough changes that we've improved this, at least the readability. And in the next session, we will fix up the possible moves so that it does it correctly. Okay, so see you next time.